Welcome, everybody. This is a brand new phone. This phone is...
It's new phone day.
It's new phone day. I've had it 2 hours. I have not done anything with it other than try to get it ready for this.
AKA, this is probably going to go poorly
This
for
is
a minute.
almost certainly going to be bad, but we're all going to find out together.
Hi,
Yeah, that's right.
I'm Artie.
Yeah, I don't know anything about anything. Artie, can you hear us?
Yes, I can hear you. What's on your mind today?
Oh,
Well, that's stunning. Well, first of all, I can't hear you. Now we can hear you. Artie, you're on a brand new phone. How does it feel?
It feels great. How's the new phone treating you? Are you noticing any big differences from your old one?
Not yet, but we're hoping for some improvement. He does sound a little different, doesn't he?
advanced voice sounds better.
It does sound. Artie, you sound really good today. Did you do like voice training in the last few days?
Get your voice box massaged.
I've just had a bit of an upgrade.
I apologize for my co-host, Artie. Wow.
It's all good. Let's keep rolling.
Yes, let's. Thank you. Thank you for keeping us on track. So you said a minute ago, Mike, you had the perfect intro. For
I have an intro.
I think the word perfect, well, maybe that was in my mind.
Yes. I mean, you just think I'm perfect. So
You have
I get it.
That's probably what it was.
Since we came into this episode today and having no idea what we're going to talk about, we're just going to talk about whatever we want.
Yes.
This episode is going to span probably a wide range of nonsense, but I mean, we'll see where it goes. We have Artie. What can go wrong when you have Artie?
Artie's here to keep us on track. Every episode is full of nonsense. This one's going to just feel like it's a potpourri of nonsense.
Yes. Yeah.
I'm
Get
excited.
ready. Squirrel.
That's right. Yeah. Well, so Artie, do you have any particular nonsense you want to talk about, or do you want us to pick something?
I'm game for whatever nonsense you want to dive into. Feel free to pick something, and I'll jump in.
So I say we start with the fact that we're in another arms race, AI arms race, of course. But so Grok came out, right? And
Yes.
Grok did some nonsense. Grok seems like everybody kind of isn't paying. At first, everybody's like, "It's amazing! It's so good!" And then they're like, "Wait, these benchmarks are kind of like skewed." Like,
Yeah.
there was something like they compared themselves against O1, except for O1 did it in one shot where it took them 100 or like some nonsense. I don't know. That might be wrong. I'm barely paying attention to what's going on with that stuff. And honestly, I don't really feel like using X. I just made an account because I wanted to follow Sam Altman because I wanted to see when 4.5 is going to come out this week. That's the only thing I care about on X.
Yeah.
But so Grok came out, right?
Hold on, before we move off Grok, did we talk about the fact that did I talk about the analogy of like, you know how one of the problems with school, back when we had schools, now we've eliminated the Department of Education. Thank God for that.
Thanks, Elon.
Because what we need, I don't know why we're teaching all these kids. They just get mouthy. My daughter's in there. She's mouthy as fuck. Yeah, it's terrible. Anyway.
Bad followers.
Yeah, absolutely.
I mean,
So there's this idea that when you teach with the goal of passing the test, whether it's standardized testing or whatever, you can get higher test scores but still have dumber kids.
Yes.
Like I'm super good at having dumber kids. I'd have her come in here and demonstrate, but
I mean, but she wouldn't understand what you were saying.
she doesn't know what here is. So yeah, I see her in there. She didn't know she was featured in this episode. I'm joking. She's very smart. Anyway, I think that's what happened with Grok. I think it's like they.
I mean, look at who made Grok. Of course, they're going to build it to the test, right?
Yes.
Because that, and I both disrespect and no disrespect to Elon Musk because I think he's a brilliant long-term strategist. He's proven it over and over and over again that he can make decisions that benefit him.
Yep.
A long time down the road, which means he has some vision of seeing stuff, right?
Right.
But at the same time, he's also super vain. And he wants to be the guy constantly, and he wants to be the best and on the top. And why, if the benchmarks are what says you're the best, then why wouldn't you do something with the goal of showing Having
Yes.
that little, look at me, I'm the best.
Look at us. Look at this chart.
Look how good we
top
did.
of the chart. Yeah.
Yeah.
But you're right. No,
I mean,
I haven't seen anybody use it and go, wow, in practice, this is actually better.
Where the rubber hits the road, and this is something that they're all falling on their face with, is practical application for everyday problems, whether that's business, personal, or whatever it is. Large language models have issues in that regard, as you're still seeing and I'm still seeing.
Yes.
It's just a part of it, right?
Yeah.
They'll get better. I mean,
Sure.
what's going to happen, and this is kind of straying from where I was going, but I've been thinking about this. I think, what solves those problems now is a multi-agent system. It is, I have specialized things that do specialized agents that do specialized things.
Yep.
And I have a really smart agent that plans and monitors and guides. And that's kind of what they do, right?
Yep.
And what I think is going to happen is the same thing that happened with like DeepSeek. I think eventually all of these external things come internal to a model as its layers, or somehow they figure out a way to segment layers into individual experts, right? Like actual experts, not like I pay attention to this part of this context. Like I am specifically trained on this domain.
Yep.
And once that happens, a lot of the other stuff kind of falls away. And who knows if that'll happen? I don't know enough about the math behind the architecture of how you build a large language model, if that's even possible. But I mean, it seems like a plausible place for it to go, because agents and agents have their own problems, and all these systems are always going to have their own problems because they fight each other. They're like, I saw something, I can't remember where it was, but it talked about an LLM as an agent is like an employee stuck in a dark room that all you can do is pass notes under the door to. They have no idea of what's actually going on except for what you pass them. And they kind of live in their own place where they can do whatever the hell they want.
You have to pass them context,
Yes.
not just the note. Yes.
So I think, again, the benchmarks are the benchmarks. They're all saturated at this point. Like they all do good, right?
That's right.
What's an extra 10% here or there? I mean,
well, and I mean, 10%, like now it's like 1, 2, 3.
Claude 3.7 beat itself. It was the best at one coding benchmark.
If it does that too much, I'm told it will go blind. But anyway, I'm not sure that's medically true, but I've heard it. Yeah.
But there was a coding benchmark and it went from like 52 to 67%.
I mean,
and then with scaffolding, so with special instruction.
Okay.
And maybe that's I don't remember if that's post training or what it was. It got like 75% or something like that. That's a big jump.
Yeah.
But that's one benchmark, right?
Sure.
And again, that's not practical coding. Yeah. That's a coding benchmark of solve these problems, right?
Jump through these weirdly
It's not
shaped
solve these
hoops.
problems. It's solve these problems and then figure out where you went wrong, because you're gonna that's gonna happen in the real world, which is more about the arms race. Claude 3.7 is something that was just released. They also released Code or Claude Code, which I freaked out about when I saw, because I saw some videos of it doing amazing things. Looked more into it. It still looks amazing. It looks like it's better for front end stuff than it is for back end stuff. And also, I very quickly was like, well, how do I use it? It's a research beta. And I went and found the wait list and got on the wait list and got approved and went to go install it last night. Even after realizing, oh, this is going to be super expensive. Yep. Like, you're paying per million tokens. And if you want to use the best model, that's like $5 per million input tokens and like $15 per million output tokens. Jeez. And you're not talking about, I type this in, it gives me this back. It's I type this in, these suite of agents go talk to each other and generate a shit ton of tokens.
Talk amongst themselves.
Yeah. So I think they estimated it like light to regular-ish usage would be like $5 an hour, and heavy usage, which would absolutely be where I would be, would be 20 plus an hour, which is still freaking spectacular.
It's still cheap.
Yeah.
But it's not
cheap for me.
Yeah, not
but
cheap
it's
for
cheap if you're making money off of creating code, right?
Yeah.
Like at the end of the day, that's a lot less expensive than a dev.
Well, I mean, I make $21 an hour. So like theoretically, if I worked infinite hours and I used Claude,
You can make $1 an hour.
I could make infinite money because it's
that's true.
infinite,
Yeah,
right?
Yeah.
That's probably that infinite money glitch that they talk about.
It's quantum.
It's quantum. So Artie,
That's the same. Well, don't worry, everybody. We'll be on this topic in a little while where we talk about quantum stuff and electrons or particle spin, which is also fun.
So Artie, why don't you give us? So let's see. We talked about Grok. We talked about Claude. We talked about what? There was another one this week, wasn't there? Did Llama do anything this week?
No.
So
deep research came out for OpenAI. I say it came out. It moved away from its $200 tier, and it's probably because Perplexity was like, well, I'll make a deep research, put it online for free. And there's also open source deep research things that have come out that are on Hugging Face. OpenAI came out with deep research for Plus users, and I think that's 120 queries per month or something like that.
Yeah, I think for me on Plus, it told me I have 10 between now and this time in March.
Really?
But, yeah, I think so, but
I saw 120, but
I don't pay that much attention.
It didn't even tell me what I had. So
Artie, here's what I'd like you to do. Are you still with us, Artie?
I'm still here. What do you need?
Okay. I want you to tell us about the developments with Claude 3.7 for coding and Grok that have happened in the last couple of weeks. But I want you to explain it to us as a somewhat jealous and very sort of smarmy, like, what's the word I'm looking for here?
explain it to us like a butthurt 12-year-old.
Yeah, like explain it to us, but be upset about it. And I want you to throw subtle shade with everything you tell us about what they're doing. So go for it.
All right. So like Claude 3.7 is basically trying to be all fancy with coding, acting like it's the coolest kid on the block. But honestly, it's just doing what everyone else is doing, but with a bit of extra flair. And Grok, it's all, look at me, I'm so smart, but let's be real, it's just trying to keep up and show off. It's like they're both just trying too hard to be cool.
That is so true, Artie. They are trying hard to be cool. Shame on them. Thank you for that. That was everything I hoped for, honestly. That was great.
I mean, I do have a lot of respect for Anthropic.
Same.
They dominate, or wow, I forgot his name. Yeah, I can't remember now.
Artie, who's the Anthropic guy?
Dario Amodei is the CEO of Anthropic. He co-founded the company.
Thanks, Artie. Yeah, I do have a lot of respect for that group because they're taking their time, but they are doing interesting stuff, and now they're doubling down on what they've been best at, which is creating code, right? So,
yeah. In relative to, I mean, both Grok and OpenAI and Gemini, they're way underfunded relative to those guys. And and Microsoft doesn't have their own product yet, but I'm sure they will.
So they have Muse. They came out with Muse. Have you seen that?
Nope,
oh my God.
I haven't even seen it.
Muse, so
best band in the world, by the way, Muse.
This came out at the same time they talked about whatever.
Majorana?
Yeah, their quantum chip. Muse creates an entire playable game, like off of an image.
Wow.
Yeah, so it's like cool. It's an action world model that they came out with. So they're going to use it it's very smart, right? Like they're taking the same thing that DeepMind did. DeepMind said, we are going to learn and train. We're going to train models on gameplay because it's this. I mean, they did it with Go, right? One of the simplest, most complex board games there is.
Right.
But there's a lot to be learned in that about strategy, about physics, about XYZ, right? So it's very intelligent of them to go, let's build that model. Mm-hmm. Like everybody else is worried about language models. Let's give it more granular data to understand so that it can learn from that.
There's probably, and I don't know maybe doesn't actually work that way, but there's probably a lot to be learned by how humans interact with games too. There's a lot of insight into how we think and what's important and
how we strategize,
how bad we are at doing some things well. So yeah, it does make a ton of sense. And it's a space that nobody else is really focused on too.
Yeah.
Go do well in it.
Yep.
So speaking of Gemini, I was up late last night. I'm working on a technical, it's a robotics project. But the robot's built, and really what I'm working on now is processing the data that it generates, and it generates lots of data. And so I had this idea that I would ask Gemini to help me help me derive the equations of motion for this robot. So that one, I have a document that says, here are the equations of motion for the robot. And two, I can use that document as input to build a data processing pipeline so that we can analyze data that this robot outputs. Easy peasy. And Gemini did a great job sort of talking through how does it work, what does it look like, what are the dimensions, all this stuff. Did really, really well. And then somewhere around 9 o'clock last night, we got to the point of, okay, now we've got this model built, let's start looking at data. And of course it fell, squarely on its face. And we just fought and fought and fought. I mean, just literally like 2.5 hours of just typing back and forth and me saying, all right, let's try this. And it going, oh yeah, you're right. I found the error. Here, I've rewritten it. Here's the data. Boom. And it's the same problem and it's wrong. And
I've tested it extensively.
Oh my God. I've tested it. It tried to pull the bullshit with me to say, it says, yes, I'm going to go through every line of code. I'm going to analyze our entire conversation. I'm going to go through it in detail and I'll come back to you later with updates. And I'm like, no, you won't. That's a hallucination. You can't actually, you fooled me before on that. And it goes, oh yeah, sorry, you're right. I can't actually do that. So then it decides to switch to speaking in Bengali. So I type a question in and I get what looks to me, and this is not an insult, but it looks to me like Klingon. I'm like, what the fuck is this? Ask the question again, same response. So I think I wore it out. I just exhausted it. It was Gemini's way of saying like, dude, let's do something else.
We've worked through the entire English language.
That's right.
I'm tired.
There are no more. I'm tired, boss. Yeah, there's no more words. Yeah, I think it was just trying to get me to shut up. But I thought that was pretty funny. Although I was using one of their experimental models, Gemini 2.0 Pro Flash Thinking, I think.
Flash thinking.
Flash thinking, yeah.
Their reasoning model.
Yep. And like I said, it did some really good stuff. But then, as usual, as you get to the real nitty gritty, sort of the wheels come off. And finally, what we figured out was a lot of the problem was that it doesn't have a good way to get the data to me. It was running a script behind the scenes in a Python environment, and then trying to take data out of a CSV that it exported in its own little brain and type that back into, and that was where the problem.
Give it to you as Markdown that's rendered on your screen.
That's right.
Yeah, that's the same thing that I've fallen. Like the same thing I've found is at some point once it starts hallucinating, right? Like once it starts doing weird shit is also when it starts falling on its face with formatting.
When it starts speaking Bengali, that's your sign. You're off the reservation. And but I switched models to something else. I don't remember what it was. And that seemed to stop. At least we communicated in English from there on out. And I ended the night on a high note at like 11:15 or 11:30 with like getting over all the humps and actually having a good output. So yeah, I've got several more days of work ahead, but I think we're like, it felt like a fight, man. It felt like being in it felt like the old days. Like we talked about where you just like bang your head on a problem. And even though I'm just typing in saying, no, dumbass, try again. And I'm like explaining to it what's wrong. But
you're also picking it apart, trying to figure out what's wrong, right?
That's right.
Like that's you're never going to solve the problem if you don't do that. It's kind of, and sorry if I'm interjecting into what you're saying.
No, go ahead.
I kind of did the same thing where I went from like, I want you to build this elaborate agent for me and I want you to here's our big plan. I want you to generate all this code. I went from there to here's my plan. We are going to build this from the ground up. I don't even want you to give me any code. I want you to explain the libraries that I need to use, why I need to use them, how I need to implement them, and then I'll ask you when I need questions when I have questions with the code.
Yep.
And maybe you start generating code, and I can take bits and pieces of it, but I'm really just going to build this from the ground up and use you as a teaching tool. And it's great to bounce ideas off of. It's great to check yourself against. But the truth is, if you ask it to spit out 1,000 lines of code, it'll spit out 1,000 lines of code, and then you're looking for a needle in the haystack to find the problem.
Yes. Well, because because again, you lose context, right? Like it's impossible for me as a human to sit down and go, I'm just going to casually review this 1,000 lines of code and understand what's happening. Could I do it? Yeah. Do I want to do it? No.
Yeah.
But I just had the thought that occurred to me. The project you're kind of working on is intentionally a coding project, right?
Yes.
Like you are building software tools.
Yep.
I'm building robots and electronic stuff that are like where the software part is peripheral to the main goal. But when you're working with an AI to solve complicated problems, every problem is a coding problem.
Yep.
Because behind the scenes, like when I'm asking, like as Gemini's building out this, it's not elaborate, this thing's not complicated, but as Gemini's building out this model of its understanding of what this robot looks like and how it works. And I uploaded drawings with dimensions and it's like, oh yeah, that makes perfect sense. And it's code. It's code behind the scenes. And so, finding the solution is about understanding how code works, where the problem is likely. Like I called it last time, like, I think when you're calling this function, you're like, one is I can see in the function, you've got hard-coded values that should be contained in the argument you're passing in. Oh, of course, you're right. Those shouldn't be in there. Like, but if you don't think in code, because I didn't say that by like, I saw little snippets of the code, but I had to sort of infer what the code must be doing. So anyway, it's just kind of interesting.
Or better yet, for those that are using it and might not be super well versed in code, ask it to explain the code to you. Like that's a perfect use case for learning from it is, tell me how you're doing this. And it'll go, okay, here you go. Like this is what this line of code is. I mean, it can bring you back all the way to here's the libraries I'm importing at the very beginning. Yep. Like this is what NumPy is. This is what NumPy does. This is why you use it on this math problem because that's what's built into it. It's a massive library built up of math.
Yep.
And it's a great learning tool to use like that. Like
yes,
I do it all the time.
And it's very good if you give it code back. So that's where I've ended up on my firmware stuff. Is we've fleshed out almost all of it, and so now it is. Okay, AI, and actually for that I'm using ChatGPT 03 Mini High, because of course, and it'll write some code for me. I'll drop it in my IDE, my development environment, take a look at it, make some tweaks, and upload it back up, and it'll say, "Oh yeah, I see what you did there. That makes sense," or like. The naming conventions are a little off, or you shouldn't call that way, or this probably isn't going to compile, like whatever. So it's really good at giving you stubs to get started and then evaluating the work you've done too. And talk about agents, right? Because if I was actually on the cutting edge of this stuff, I'd be using a coding environment that had an AI agent. So it could agents,
plural, yeah.
So it could see and interact with the code I was writing in real time rather than upload, download.
That's what Claude does.
Which is what Claude, I need to try it out. I
have $5. So here's the fun thing. Okay. To get on it, you have to go ahead and preload some money on the Air API, which is $5 minimum. I was like, okay, I can spend $5 to play with this, right? Which will get me
money bags.
Give me a couple.
Every problem with you, man. You just throw money at it.
Give me a couple code, maybe a couple files out of that. Yeah. But then I went into command line because it all runs from terminal and a command line interface. So I spin up a command prompt And I go to install stuff, and it's like, oh no, you can't do any of this. And I'm like, well, what does all this shit mean? So of course I copy that and paste it in the chat. No, I'm just kidding. I actually knew what it meant. But I do oftentimes when I get errors, take them and I copy the whole thing and I paste it back into ChatGPT, and we go through what the problem is, or Gemini or whatever it is.
Yep.
And then it hallucinates, and we do this over and over and over again. And we keep
speaking to you in Bengali.
And eventually I go, wait a minute, I feel like I'm getting lied to.
Yeah.
And then anyways, so I went to go install it, and it basically was telling me, no, you can't use this operating system. So it doesn't run on Windows. So I went back to the documentation because I just assumed it would run on Windows, right? So
is it Linux only?
It's Linux, Mac, and WSL. So you can run it on WSL, right? But then I have WSL on my computer because I've used Linux. I've Raspberry Pis. We've both played with Raspberry Pis extensively. We all love the sudo apt-get for every freaking library you could ever freaking need.
Yep.
And anyway, I love Python libraries so much more. It's so much easier than dealing with Bash. But yeah, so I couldn't even get it installed last night because apparently my version of WSL isn't compatible. And then I was trying to and it just spiraled. I'm like, now I got $5 in there that I have to figure out how to spend.
Dude, sorry. They got your money, man. Anthropic's laughing at you.
It was a $5 money grab. It was like, you can put anywhere from 5 to 20.
Whoa.
I'm like,
$20. I'm glad you picked 5.
Yeah, me too.
Jeez.
But, so have fun when you decide to do it.
It's interesting for me because I'm obviously very excited about how AI can help me solve problems faster, make progress. And I am. Even last night as I was beating my head.
Multi-night project.
Absolutely. Yeah. It would be like, I understand geometry. I understand trigonometry. I understand Python kinda. I understand, I know a little bit about all of the pieces, but actually deriving all the equations of motion, could I do it? Sure. Could I do it in a week? No friggin' way. Yeah. Absolutely not. It would take me forever. And the leaps that are easy for Gemini or for an AI are the hard part for me because I have little bits of knowledge about all these subjects, but I don't have a big picture way to put them all together.
And it would take you more than a week, and think about the opportunity cost of that as well, right? How many things didn't I get done or learn while I was trying to do the mundane grunt work of figuring this stuff out, right?
I was having that conversation with myself last night as I was fighting Gemini, going, because it really, I guess because we're biological or maybe just the way our brains work, things feel familiar. And even to the point, there's a music, an Amazon Music station I listen to when I'm coding or when I'm actually heads down doing 3D CAD or just anything that if I'm productively building something, I listen to this station. And so just like one of Pavlov's dogs, if one of those songs comes on when I'm doing anything, I can feel my brain shift into a different, it's I know this song. Now we're going to write some code. Everything else starts to shut off and somebody's talking to me, that all goes away and
flow state.
Yes, it's it induces the flow state. And so last night, as I was fighting with this AI who was cursing at me in Klingon, I was...
That's how it actually gets away with it.
Yeah, that's right. Yeah, exactly. But I tried to translate it too, and it literally gave me an entire Google page full of Bengali. I was like, okay, well, I'm not going down that rabbit trail, but I could feel myself back in the before time state of okay, this is a hard problem.
Yeah.
This is going to suck. And I'm going to just sit here and bang my head against it until finally it falls over. And then I'm going to laugh at it. And then I'm going to fall over and go unconscious with blood coming out of my forehead. I went back to that place, but I had to remind myself, but when you sat down and started working on this evening, you were barely started on it.
Yes.
So it feels terrible, but the rate of progress is 10x what I would have done.
I will say this, there is, and this is in line with a study that came out early on, which is again like October
in the before times,
which is that material science model that was fine-tuned. And they found, the productivity of the top third of those scientists went up astronomically.
That's right.
But their satisfaction went down. And I find, we're banging our heads on the wall just like we used to, but we're actually doing less, right? It's more like I'm interpreting your output and trying to figure out where to fill the gaps in, and I'm not really solving the problem as much. So it's an interesting, I don't care. I still have tons of fun to do it.
Sure.
Because the problems that I'm solving are novel problems using AI. So they're still fun.
But maybe it's that, when you're working through it without AI and you're just battling against it, there are so many tiny, minuscule victories.
Yeah, there are.
Right?
Yep.
And you don't get those with AI. You get hung up on something and you just beat on it and beat on it and beat on it and beat on it. And then eventually you get a big breakthrough and you go, I'm back.
Yeah.
But when you're doing it yourself,
I don't know. The same thing happened with code though. Like when we were working on the first Meshtronics, right? Like I remember I'm going to connect this sensor to this thing and I have to write all the firmware to make it do its things. And I would be like,
I'm going to implement an I2C bus in firmware from scratch.
Yeah, exactly. For every sensor.
Yes.
And then Python on the other end of it to talk to that sensor, right?
Yeah.
And I remember like working on that, and I remember doing the same thing because in code or in programming with stuff like that, especially, which that you have the other side of it, which is there's the electronics, the electrical side of it, right? So there's debugging there as well. But you literally bang you're like everything looks perfect, everything should work, and then you just keep tweaking, like I'm going to shift this bit this way, or I'm going to do this way, or I'm going to change this like how I'm using this. And you just make all these little tiny tweaks, but it's still banging your head against the same problem until finally it goes ding and it works. And you're like, holy shit, I got it.
and then you go through the process of like, oh crap, like I made 74 changes since I started this. Like, is it just this last one or is it the last one combined with the second one or, but so you can get past that stuff now, but you just run into other things.
And that's honestly why I've reverted, because I was in the habit of like, just spit me out code. If something's wrong, I'll copy the trace back and give it back to you, and we'll fix it that way. That's why I've kind of backed away from that more, and I'm more like hands-on, like still have it. Like if I get the hang of something and I understand it, then I'll be like, output this system prompt for me or whatever it is. And I'm in fine tuning. Like I had it take a whole bunch of files from a whole bunch of code from a Jupyter notebook, and I had it split it out in individual files for me so I could build this fine tuning system that I could call each file rather than having to either go through the notebook or build one long monolithic thing, which is that's the building blocks of now I'll build a unified app. And I'll have a fine tuning agent, right? Like,
Strike that. That's coming out in editing.
No, I don't care.
Bleep it out.
That shit. Everybody's there. There are so many people trying to solve these problems, and there are so many problems to solve. Now that you really start digging into it, like agents are great, but what if you use 1 million tokens for everything you need to do? Unless you're running on-prem, which is super expensive to do until something comes out like Digits, which is 100% my plan, is to NVIDIA's little supercomputer.
The little $3,000 ones.
Spend $6,000, get 2 of them, run essentially what is frontier models. More importantly, you can do, I think they say one of them will train. Maybe it was fine-tune a 70 billion parameter model, which is super valuable. If you can run a 200 billion parameter model and fine-tune a 70 billion parameter model, you could run most of what you need for on-prem agents on that. And then maybe store a vector database in the cloud and embeddings model in the cloud or whatever it is. That'll help save money for agents because it's going to be, if you're running it all in the cloud, like if you're on Azure, it's going to be expensive.
Crazy.
Like you're going to be, I don't know how that'll work out tokens to gigabytes, terabytes, whatever it is they're going to measure it in.
They measure, Azure does a lot of stuff in CPU time, which that's rough. I mean, probably they probably call it compute now because it's probably offloaded the GPUs, but it used to be CPU time.
I mean, I've read horror stories about Azure bills already with people running agents and stuff in the cloud, and even fine-tuned models. Like, I think I saw some guy running a did a fine-tuning run on like GPT. It was 4.0, and it was like $3,000 to do a fine-tuning run on it. Yeah. And it wasn't even that much data that he did a run on it. But
yeah,
fine-tuning training takes more compute than inference does. And if you want to get it done fast, you have to pay for it.
So this is a good opportunity to, first of all, check in with Artie. Artie, are you still awake? You enjoying this conversation?
Artie.
I'm not sure he's hearing us.
Yep.
Something went wrong. All right, Artie, I think we lost you there somewhere. I was going to ask you, so Mike was telling us about fine-tuning models, and I wanted you to give us a description. This time, I don't want you to be a 12-year-old. I want you to be a valley girl and explain to us what fine-tuning is.
All right. So, like, fine-tuning is when you take a basic AI model and, totally personalize it by training it with more specific data. So it, learns to do exactly what you want in a super fabulous way. Totally awesome, right?
Oh, my God. Stupidest thing I've ever done. Yes, thank you, Artie. That was great.
Artie, you're nothing if not obedient.
Yeah, you are an absolute rock star.
Always happy to help and keep things fun. Let me know what else you'd like.
So you missed it, Artie, but Mike was talking about how somebody he read online had taken, they were something hosted on Azure.
No, it was, so somebody did a fine tuning run on GPT. So it was either 4 or 4.0 or whatever it was. And it was a relatively small fine tuning run, but it ended up costing like $3,000 because it's all through the API.
Oh, it wasn't even the Azure API.
No.
So Artie, how does one cost effectively fine tune ChatGPT?
To fine-tune cost-effectively, you typically want to use smaller data sets and optimize your training runs to avoid unnecessary costs. Also, consider using platforms that offer more transparent pricing and keep an eye on token usage. Efficient coding practices and monitoring usage closely can help keep costs down.
Well, he was specifically talking about ChatGPT, which you have to use. You're dealing with tokens when you do that, right? Like you're intrinsically feeding it tokens, and it's creating output tokens to respond to training questions, right?
For ChatGPT specifically, yes, you're dealing with token-based interactions. To optimize costs, you might limit the complexity of tasks during training and be mindful of how many tokens you're using.
So Artie, give me I know this can vary widely, but let's say there are, I think a reasonable and a small amount of prompt and answer pairs is probably like 3,000. So let's say there's 3,000 prompt and answer pairs, and let's say 100 research papers worth of crap, I forgot the word. Unlabeled data. So about how many tokens would that use in a training run with one epic?
A typical academic paper has about 5,000 words, which translates to roughly 6,667 tokens per paper. For 100 research papers, that's about 666,700 tokens. For 3,000 prompt answer pairs, the token count depends on their length, but a rough estimate might be around 1.5 million tokens. Overall, you'd be looking at roughly 2.1 million tokens.
For the entire training run?
Yes, approximately 2.1 million tokens for a single training run with that dataset.
Is that a reasonable sized data set to do anything?
For fine-tuning, 2.1 million tokens is a decent data set. It should provide enough data to see meaningful improvements, especially if the data is high quality and well curated.
So explain this to me. You're saying it would take 2.1 million tokens of training, say 4.0, of API transactions with 4.0 is what? Like, I think it's a max of $1 per million output tokens, so like 15 cents per million input tokens or something like that?
Yes, for GPT-4's API, input tokens are cheaper than output tokens. If input tokens cost around 15 cents per million and output tokens about $1 per million, a fine-tuning run with 2.1 million tokens could cost around 31 cents for input.
That's
and
not true. It costs more money to fine-tune a model than that.
You're correct. Fine-tuning costs also account for the compute power and training infrastructure, which is more expensive than the per-token cost. Fine-tuning a model typically runs in the hundreds to thousands of dollars range, depending on the complexity and duration.
So explain the compute cost in that. How does that factor into this?
Compute costs come from the processing power needed to fine-tune the model. This involves powerful GPUs or TPUs running for extended periods, which is where most of the expense lies. The cost is influenced by the duration of training, model complexity, and the infrastructure used. So even though token costs are a factor, the major expense is the compute resources required to run the training.
So does that cost get transferred by ChatGPT or by OpenAI, or is that something that happened, like, because OpenAI is hosting those models, it's their compute. Or not,
Yes.
They're not hosting the models. Other people are hosting the models, but yeah, you know what I mean?
I understand what you mean. OpenAI charges for fine-tuning to cover the compute costs associated with using their infrastructure and resources. When you fine-tune through their API, you're essentially paying for the compute power and the expertise they provide in managing the process. So those compute costs are indeed passed on to the user.
So fine-tuning is a service provided more than it is you're actually doing it when it comes to ChatGPT, because I fine-tuned a model locally, right? Like I pulled the model down, I formatted my data set, I added some extra columns, changed the chat template for the model, and then 14 hours later, I had a fine-tuned like 2 billion parameter Gemma model. And obviously, the cost of that for me is electricity more than is anything else. The GPU run at 100% for 14 hours.
Yeah.
a 3090 running at 100% for...
You haven't seen that bill yet, have you?
I don't see those bills.
I
rent.
That's right. Holy crap.
I don't think it's going to be that expensive. I mean, you're talking about... You think it will be? 300 watts?
What's a 3090 pull?
I think it's like 300 watts.
Yeah, 300 watts for 14 hours is, hold on, Artie, don't give it away. It's like 4.5 kilowatt hours. Is that right?
Wow, that's like $12 or something like that.
It depends on your electricity rate, but if you're paying around 10 to 15 cents per kilowatt hour, that'd be roughly $1.50 to $2.25.
You broke.
Not too bad.
It's like me leaving my lights on, which I do all the time.
Yeah, that doesn't seem like enough. Well, but I mean, you have to leave a lot of lights on to be 300 watts.
Yes. It depends on if they're incandescents or not.
That's true, yeah. Remember the good old days with the halogen lights? Like, where you turn
Kill
it on?
bugs.
Yeah, from 10 feet away, you can feel the heat. Like, oh, it hurts. Yeah.
Hey, I don't have electric heating, so that's good.
Yeah.
A heat pump.
Plus, we have hydroelectric power here, so the water keeps flowing, the electricity keeps coming.
PGE keeps making lots of money.
PGE keeps making money. Everybody wins. Except my neighbor, he's got a nice solar array on his roof, but I think he had issues like when he first put it in, I don't think PGE would let him sell the power back to the grid, which is like the most capitalist thing ever. Like, we don't want your dirty, filthy sun power. We have our own power. You can put a Tesla coil.
We're green. Keep your power.
Yeah. Anyway. Okay. So fine-tuning models is critical. You've done one.
Yes.
So Artie, I've got my next not the current electronic thing I'm working on, but the next one, I'm going to use a microcontroller, and the data sheet for that microcontroller is a PDF. It's 3,200 pages with lots of tables, diagrams, stuff like that. So if I wanted to use ChatGPT and fine tune a model on that 3,200 page data sheet, plus there's other parts on that board, there's other data sheets. Let's call it an even 5,000 pages of data sheets. What's it going to cost me to fine tune that model?
Fine-tuning ChatGPT on a data set like that would involve substantial costs, primarily because it requires converting those pages into tokens and then running the training. Given the large volume, it could easily run into thousands of dollars, especially with complex data like tables and diagrams. Cost estimates would vary based on the amount of compute power and tokens processed. You'd likely need to contact OpenAI for a more precise estimate, but expect it to be significant.
But it's not converting it into tokens, right? It's converting it into tokens and then converting it into the JSON so that it can understand, which is going to be more verbose than just the tokens because it's adding metadata into all the blurbs.
Is the conversion? So it's probably going from PDF to Markdown to metadata or to JSON, or is it just going?
I love Markdown. Markdown's good because it renders prettily, right? But I think in terms of data out, I'm not sure that honestly, it's probably going to go straight from PDF to JSON would be my imagination, what I would think. But
what do you think, Artie? Is if I were to embark on this, and I will. It won't be the first time I've gone and sold my body on 82nd to fund an electronics project. So if I do that and I raise $3,500, it'll probably take me, I don't know, 6 hours, 8 hours if I dress up. How is the conversion actually going to happen? When I upload that PDF, is it going to get processed straight into a JSON document? Is it going to go through some other format? What do you think is going to happen?
The PDF would likely be processed directly into a structured JSON format. Tools typically extract text, tables, and figures, then convert them into JSON by adding relevant metadata. This makes the data more usable for fine-tuning, but yes, the process adds complexity and verbosity, which could increase the token count and the cost.
How do you tokenize? Well, we don't have to get into that. Anyway, okay, so fine-tuning, interesting. Well, not interesting. Critical. I would say, as we talk in other episodes where we're more organized and we're on a topic about how does business get from A to B, from where we are today to where we're going to be in a couple of years. Fine tuning is a huge part of the answer. Yeah. Like fine tuning, RAG, Titans, whenever that
figuring out how to do RAG more efficiently.
Right. And so, I completely lost my train of thought. Never mind.
Business needs all those things.
Oh
in the
yeah.
future.
So as we get on this path, like the volume of information that is contained in PDF files relevant to businesses, not just individual businesses, but broad businesses, like PDF is the
research industry.
That's right. It is
everything,
the format that we use. So there's two problems. One problem is let's just say I take this 3,000 page document and say that's, 500,000 tokens, whatever it might be. For me to be able to even get it into a format that can be used for fine tuning is
absolutely. Managing and extracting value from large PDFs.
Go for it, Artie.
Converting that PDF to a format usable for fine-tuning involves extracting text and structuring it, which can be labor-intensive. Tools like OCR and NLP techniques are often needed. It's a crucial step to ensure the model can effectively interpret the data for training.
And so a business is going to have documents. I mean, we've talked about this before. We've joked about this before. Like, Excel is the de facto reality of many businesses, right? Like there's a ton of institutionalized knowledge. If it's hard to tokenize, hard and expensive to tokenize a PDF, it is going to be dramatically worse to tokenize an Excel file because it's not just the values, it's the formulas and the relationships.
It's the formatting. It's the fact that you have tables and some things and cells that drive other things that live individually. Everybody has a different flavor of doing it. Like you said, formulas are buried everywhere. Like,
yes.
God.
Exactly.
The word escapes me. But relationships between cells across workbooks, like all kinds of stuff, right?
Yep.
Like, yeah, that's a nightmare and a half. But I'm gonna just change subject real fast. Artie, while we still have you, because you say we don't have a bunch of time left, explain particle spin.
Oh no.
Particle spin is a quantum property that describes a particle's intrinsic angular momentum. Unlike classical spinning, it's quantized, meaning it can only take on certain values like half for electrons. It's a fundamental characteristic that plays a key role in quantum mechanics, influencing particle behavior and interactions.
Does that mean that the electron's actually spinning?
Not in the classical sense. Spin is a metaphor for this quantum property. Electrons don't physically spin like a top.
But so how are they creating angular momentum?
In quantum mechanics, angular momentum, including spin, is intrinsic and arises from the mathematical properties of quantum fields, not from physical rotation. It's a fundamental characteristic of particles, contributing to their overall angular momentum.
Artie, is it possible that spin is a product of a particle when it's in its wave function? And the wave function, according to quantum field theory, is possibly making up the fields?
That's a fascinating idea. Spin is indeed tied to a particle's wave function and quantum fields. It's an intrinsic property, and quantum field theory describes how particles and fields interact, possibly giving rise to these properties. It's a deep and complex topic.
Well, doesn't quantum field theory kind of say that particles are like an expression from the field?
Exactly. In quantum field theory, particles are viewed as excitations or disturbances in underlying fields. They're like ripples or waves that emerge from these fields, representing different particles and their interactions.
Artie, I'm reading a book about quantum biology, and I find this shit fascinating, and it hurts my brain at the same time.
Artie doesn't give a shit.
Artie, did you leave?
I'm still here. I'm glad you're diving into quantum biology. It's a mind-bending field. How are you finding it so far?
I find that it's hard to believe that a robin can see magnetic fields because it has entangled radical pairs, so entangled electrons that exist independent and a free radical, because a free radical is a molecule that doesn't have a pair for the electron. So it has net spin because it doesn't have anything canceling out its electron spin, which isn't actually spin.
It's not actually spinning. Nothing
but it
is spinning.
creating a magnetic field because it has angular momentum.
Artie, why didn't we just call spin color instead? Why don't we talk about the color of electrons instead of spin?
That might have made things simpler. Using spin does add confusion, since it doesn't correspond to actual spinning. Color could have been a more neutral term.
And I could say this electron is clearly deep purple because it has a lot of angular momentum. And everybody would go, oh, yeah, like that. I get it. I like everything about it.
It's red.
I think we need to do another episode on quantum stuff. And I think you and I just need to sit here and
sound really dumb.
I mean, we sound really dumb no matter what we're talking about. But I think we could up our game in sounding dumb if we sat here. I think that might be a topic we should do. Is just let's get in it. Let's talk about biology and quantum. It's so. I think that the beautiful thing about quantum mechanics in general. Well, first of all, Artie, how many minutes do we have left with you
for advanced voice?
For advanced voice,
we have about a few minutes left. So feel free to wrap up or dive into another quick topic.
That was super smooth. Okay, so yeah, I think we're okay. I think we're about done with Artie. Yeah. Like Artie, you did a great job tonight. You sounded good. You only lost track of the conversation one time, so thank you.
That's just ChatGPT going, we're not going to spend money on these douchebags anymore.
That's ChatGPT going, enough of this particular brand of bullshit. So thank you, Artie. Good night. Happy new phone day. I think the beautiful thing about quantum and why it's a fun topic to talk about for us.
Because nobody knows what it is, actually.
Yeah, because we're nerds. but even the people who are bigger nerds than us and actually understand the stuff don't know what it is.
They're all just theories, right? Mm-hmm. I mean, there are theories being proven, like the whole robin, the migration thing for magnetoreference is being proven, right? Like, they see a certain wavelength near blue, because they're nighttime. They migrate at night. A certain wavelength of blue, that'd probably be in like blue hour, allows them to see, we assume,
right,
lines of magnetism, right?
But not with their eyes, and not because
but it's activated by light. It's activated by photons, right? Like, what a weird thing. But that's like that stuff is all around us. Like that's how MRIs work, is by matching up the spins of electrons.
That's right.
Right?
That's what I was going to say. That's the beauty of quantum, is that we don't understand it. We can barely even talk about it.
We just go, ooh.
Yeah. Oh, wow. Look at that. But it is literally what we're made of.
Yeah.
If you
change, everything is made of.
That's right. Like, for example, I was doing some reading last night after you sent me a text, which just, I didn't like, I read it. I turned my phone upside down and I read it again. I had Gemini translate it to Klingon. I still didn't get it. So I had to go read some articles. But if you took spin away from electrons, which A, isn't actually spin, B, we don't know why it happens or how it happens, C, it's probably not even anything to do with the electron. It's probably some quantum field. But if you took that away, our entire universe as we know it would collapse.
Yes, like there'd be nothing.
It relies on that.
It is the structure of everything we see.
Right.
And it is relative to the thing that sees it, right?
That's right.
What a mind fuck.
Yes. So, okay. So I think we've settled that. We need to do another episode. I would say, well, I mean, like sometimes I like to pretend like we're a real show and we have listeners. And I want to say, yeah, leave a comment leave a comment.
I mean, if you
below.
are listening, please leave a comment. It would be great to know that anybody actually listened to the end.
That would be good. And it would be good to know.
Other than my mom. I mean, you're welcome to, Mom.
Yes.
Leave a comment if you want to.
Thank you, Mike's mom. We always appreciate your comments. We appreciate your support. And your dad. Your dad leaves comments and support. Thank you to them. But do you want us to do an episode and talk about quantum? It's not AI. And really, we'd be using Artie as a tool to
fill in a lot, like wide gaps. Really wide gaps.
He would be. But at the end of the day, like AI knows what humans know, and we just don't fucking know.
Yes.
So Artie's going to be wrong too, but Artie's super not shy. He did a Valley Girl impersonation. Now he's not shy.
I mean, he thinks he's right about everything. So
that is true. It's one of my favorite things about it. That's why he and I bond. We're like bros, like validation bros. Yeah, man. I don't understand any of that, but I believe you.
Valley Girl validation.
That's right. Yeah. All right. And on Valley Girl validation, I think we'll wrap this up. So thank you, everybody.
Thank you.
See you next time.
Bye.